Hello, everyone. This course, we will talk something about the new protocol, MPLS. And why we need this protocol? Because at the beginning, all the network devices for the message based on the routing and switching. And if we force a message out according to the layer 3 function, that means the message belongs to different segments. The device queries the IP routing table using the longest prefix match, right? And select and choose the best path and forward the message out. And if the network devices is not so good in the performance, and if your network is very big, there are lots of routing there are lots of segments. That maybe first time we take a long time to get the best path and then forward the message out. So how to solve this problem to forward the message out as soon as possible? One solution is we can use the MPLS, multi-protocol label switching. All the devices can forward the message out according to the label information. So about this course, we will have 4 topics. The first is the MPLS overview, and then the key point in the MPLS is a label and how to get the label. What is label? In the typical protocol, we distribute the label is LDP. And if all the devices have the label information, then how to forward the message out according to the label information. So this is a forwarding process. Then last step, we will provide the MPLS configuration. You only add the configuration, then you can get the forwarding plan and then to forward the message out. So there are 4 parts. Let's say the first part about the MPLS overview. Why we need the MPLS? That's because at the beginning, the layer 3 device use the CPU drive table, TCAM. You can think this is a routing table for the forwarding match. And this method of this forwarding has 2 disadvantages. The first is we will take a higher usage of the device CPU, and also it will provide a slow query process. That's why in a bigger network, if your network device performance is not so well, we will increase the network delay. To improve the data forwarding efficiency of layer 3 devices, Cisco proposed MPLS technology. And about the MPLS technology, all the network devices will use a new forwarding table. We call it LFID to forward the message. And about this table is very similar like the CM, like the layer 2 device to forward the message out according to the micro-address table. The micro-address table principle is I will take destination micro-address to match the micro-address table. If I find one entry is matched, I will directly forward the message out according to the entry information. So in this process, the hardware ASC chip is used for the extra search. So the speed will be faster. That's why we choose the MPLS. In the low forwarding performance of IP routing table, it's because the routing or maybe layer 3 switching based forwarding according to the longest prefix match, right? About the control plane, all the network devices will use the routing protocol, maybe static routing, maybe RIP, maybe BGP or OSPF, something like this, and then generate a routing table. Then according to the forwarding plan, all the network devices will forward the message out to find the longest prefix match. let's say the example. If now the user A and the user B want to do the communication with each other, and about the route 1, we will have the routing table, route 2 and route 3. Then, if the message sent out, the destination is 20.0.0.1, right? Source from the user A. If the route 1 receive this message, I will take the destination to match all the routing information. Finally, find this link is the best one. And about the route 2, also same, find the last path is the best one. And about route 3, maybe this link is the best one. So if you have 10,000 information, you must to match from the first routing and to the last routing. Finally, maybe you will find the fourth is the best one. But you need to take the time to match all the routing information. So this is a disadvantage if we force the message out according to the routing table. And if we use the MPLS, MPLS is a technology that features fast data packet forwarding and use LFIB to forward the message. So in this table, we only forward the message according to the detail entry. And the full name is multiple protocols label switching, and multiple protocol means the MPLS is able to operate over various link layer protocols. That means if you deploy the MPLS, your data link layer can use PPP, ATM, frame relay, and Ethernet. All the data link layer can support the MPLS encapsulation. And it also supports the network layer, includes IP, IPX, and IPv6. So it is very useful. Not means if one device deploy MPLS, all the network must deploy MPLS. No, you can use MPLS and non-MPLS technology together. So it's very convenient. And about the label, each data packet is labeled and forwarded according to the label information, not according to the IP address. And compared with your IP header, the label is very short. Okay. And about the MPLS network architecture, the MPLS network compares several upgraded routers that support MPLS, and these routers are label switching routers we call LSR. And MPLS network are compatible with non-MPLS networks, and the packets can be smoothly transmitted across MPLS and non-MPLS network. That means if there are lots of routers, right? And you can make some router to simulate, to use the MPLS network and also connect with non-MPLS network. It's very typical. For example, maybe in China, the ISP usually will use the MPLS network, but we can use the MPLS network to connect with multiple enterprise network. They only use the IPv4 network. So they also don't know what means MPLS. So the function is very similar, like the ISP provides the VPN network for them. And in this network, we have some basic concept. The router will run the MPLS protocol we call is LSR, label switching routers. And about the LSR, we also invite to become ingress LSR. That means I receive some normal packets like the IPv4 packet from non-MPLS network. And I will add some label, and this router we call is ingress router. And also some egress router. And egress router also will connect with MPLS and non-MPLS together. before we send out the message, we must delete the label information because non-MPLS network devices cannot recognize the label. And between them, there are lots of devices. If the device is only for the message according to the label information, this LSR we call it transit LSR. So if some packets from non-MPLS network, then the ingress LSR will add some label, then choose the best path for the message out, and then leave the network. So the path we choose in the MPLS network, we call it LSP, label switching path. And our very important part is how to build the LSP to select the best path. So in this scenario, we have some basic concept. The first is LSR, label switching router. MPLS network use LSR to forward the forwarding packets. And LSR can assign a label for each IGP route in the routing table, and also can advertise the label to adjacent routers. This process also is very similar like the dynamic routing protocol. And the LSR includes the core LSR and the edge LSR. Core LSR is a function like the topology, we call it transit LSR. And the core LSR are part of MPLS domain. All the interface of the core LSR can forward the path according to their labels. We only forward the message according to the label, not about the other information. But about the edge LSR, we will have the ingress LSR and also egress LSR, right? We have two types. And we also call the edge LSR to become LER. And they are the edge device between MPLS network and the non-MPLS network. The typical non-MPLS network is IP network. And about the edge LSR, some interface will belong to the non-MPLS network. So this router must recognize the information, for example, like the IP, and also can encapsulate the message of the MPLS label, and then forward the message out according to the label information. So this is LSR. And another one for the LEC, forwarding equivalence class. And how to assign the label, right? For example, later we will explain the label. The label is a value. Maybe you can see, also we have the one range like the 120 or 30. Why we assign 30? And which one should use the 30, or maybe which one use the 20, something like this. We can assign the label to the data packets according to the forwarding equivalence class, we also call FEC. And the MPLS puts the packets with the same function to an FEC and forwards these packets in the same way. In the same way means we will use the same label. And some common FEC based on the same destination IP address, we will use the same label. Or maybe same source IP address, we will use the same label, or maybe QoS, or maybe some layer 2 identifier. And by default, the MPLS creates an FEC based on the data packet's destination IP address and assign labels to the packets. So this is a basic one. And later, when we explain the command, we also will check the MPLS assignment. You can find some special routing information. We will assign some label, and this routing we call it the destination IP address, right? And the next part is about the label switched path, LSP. A label switched path is the path we select in the MPLS network. Okay, and this path will determine how to force the FEC, use the label. And pay attention, the LSP is unidirectional path between the egress and egress of the MPLS network. That means the traffic from left to right, or maybe right to left. You have to create two LSPs. And setting up an LSP is to bind an FEC with the label together. Okay, so this is the basic function of the LSP. And about the LSP, you can manually set up a static or maybe use the protocol, label distribution protocol, LDP, to set up a dynamic LSP. And the different way is the static LSP, you need to manually configure the FEC label on all the LSR along the path. So if your network, you have lots of segments need to be forwarded out by the MPLS, the work is very big. So in this scenario, maybe you can choose a dynamic way to use LDP to distribute the label with the neighbor together. And then everyone can get the label information and then forward the message according to the label. So we also will have a big topic, how to work with the LDP. And in the static LSP means maybe some very important service. You can directly assign the static label and every router must forward the information according to the fixed LSP. So the different scenario. So about this video, we will explain something MPLS overview information and know some basic concepts. And the next part, we will go to see what is MPLS label and how to build the LSP.